Assalamu alaikum and welcome to the presentation. Today I am going to discuss about the topic traveling salesman algorithm and Bitonic sorting algorithm. Before starting the presentation, I would like to introduce myself. It's me, Pardin Alam Alif, and the presentation is presented to our honorable teacher M. Wahidur Rahman Shuman sir. Traveling salesman algorithm. If you look at the name traveling salesman, so we can guess that the algorithm is based on a salesman who used to travel and sell his product. So a traveling salesman sells his product from one city to another city. And what is the main motive of the traveling salesman? The main motive of the traveling salesman is to get the most out of the profits. So he has to consider all the cases that can decrease the cost or during his travel or during he sells his product. So how can he reduce the cost? um, he has to reduce the cost by traveling the lowest minimum path or shortest path, or he can travel the way that cost him less. Let's see. So while a traveling salesman start his journey to sell his product, he has a lots of way. He can go from one city to many cities, but he has to consider which city will be closer to him. Then it will going to reduce his cost, and he's going to get the maximum profit. So here are some nodes and vertex and edges. So we can say there are some nodes and some edges. Suppose a traveling salesman start from A and goes to B. So A is a node and B is another node. We can consider those nodes as cities, and the distance between it, the edges, can be considered as distance or cost or time, anything. Here you can see there is a graph. We can state the adjacency matrix of this graph. So here a traveling salesman can start from A or B or C or D, but at the end he have to return to his city. Maybe he's starting from A, at the end he have to return to A. He can goes to any cities by any path that he wants to choose. So here is the adjacency matrix. Here from A to B it will cost him 10, from A to C it will cost him 15, and at the same way from C to D it will cost him 5. So there are lots of paths, but from A to A is 0 because it's the same city. Greedy algorithm. We can choose many kind of approach such as greedy algorithm or dynamic programming. We have to see which process or which approach get us the best possible answer. If we choose greedy algorithm, suppose the salesman starting from A, so he can go to either B or C or D. So he have to choose the best way from these possible paths. So if we see, he can go to B or C or D, but B will cost him less. So in greedy algorithm we choose the best way, or we choose the best possible answer at that moment. From A he can go to C or D, and D will cost him less, so he will go to D. Then from D he has the only one option, is C, or he can get back to A, but he have to go to all the cities and at the end he will get back to A. So he will go to C and at the end he will get back to A. And this process or this way or this path, whatever we say, it will cost him 55. So let's see, is gradient approach is the best way to get the traveling salesman algorithm or anything else? We can use dynamic programming approach. Let's see what happen if we take dynamic programming approach. You have to say consider all the cases how he can go. So he can go from A to B, then C, then D, then E. So he have 6 possible ways. I will talk about how many possible ways it will going to we will going to get later. So here, from this path it will cost him 55. From this path it is going to cost him 51. It is the greedy approach that we had taken the last time. This path will cost him 70, and this path 10 5, 10 5, 50, 35. Then this path will cost him 70, and this path is going to cost him 75. So from all the possible paths, it is going to cost him the lowest amount, or lowest amount of time, or lowest amount of distance, or lowest amount of cost, whatever we say. This is the best possible path or way. So we can get a best way if we don't use greedy approach in this case. So if we use dynamic programming approach, we will get the best possible solution in traveling salesman algorithm. So what is the time complexity of traveling salesman algorithm? So here you can see there are, we considered 4 nodes, okay, 4 nodes. So there are 4 cities he have to visit, and at the end has to back to his own city. So there are 5 cities, but starting and end is always same, and at the middle other nodes are changing. So there are possible total cities are n, and changing n minus 1. So what is going to be the possibilities? The possibilities is n minus 1 factorial. So the time complexity will be order of n factorial, or order of n to the power n. It is the biggest possible time complexity. If we consider the time complexity by dynamic programming, the case is also the same. So total number of possibilities are n minus 1 factorial, then the time complexity is also order of n to the power n. So the time complexity is also the same for dynamic programming approach. So we can say it is an NP complete problem. I hope my fellow classmate has already described about NP, NP hard, and NP complete problems. So now we can talk about the Bitonic sorting algorithm. What is Bitonic sorting algorithm? Before knowing about the Bitonic sorting algorithm, we have to understand another concept, Bitonic sequence. Let's see what are they. Let's move to the introduction. Bitonic sort is a comparison based parallel sorting algorithm. It converts a random sequence of number into a Bitonic sequence, then it performs sorting. Bitonic sort take order of n log n comparison. More expensive when compared with merge sort n log n. Then the Bitonic sorting is better than parallel implement in hardware and parallel processors array. Let's see what is Bitonic sequence. Before understanding Bitonic sort, we have to understand Bitonic sequence. A Bitonic sequence is the sequence where first half is increasing order and the later half is in decreasing order. So if you consider an array, so Byton is Bitonic if there exists an index I where I is greater equals 0 or less equal and minus 1. So the first half is increasing order and the second half is in decreasing order. A sequence it is a rotation of Bitonic sequence is also Bitonic. Okay. What is Bitonic sorting? So we already know about Bitonic sequence. So Bitonic sequence, it is first half is increasing order and then the later half is in decreasing order. And Bitonic sorting, after making a Bitonic sequence, we have to sort this sequence into increasing or decreasing order. So let's see. Consider two consecutive element as Bitonic sequence and apply Bitonic sort on each two pair element. In next step, take four element Bitonic sequence and so on. So it seems like quite complicated, but while I will describe about the process or by pictures, then it will be easier. So n random number are converted into Bitonic sequence. Then the second step, perform compare and exchange sort. So first step is making a Bitonic sequence. The second step is making a sorted sequence. And we have to repeat the step 1 and step 2 until all the number is in sorted sequence, or all the elements is in sorted sequence. So if we want to perform Bitonic sorting algorithm, the number of elements should be the power of 2. For example, 8, 16, 32, 64, whatever it is, but it have to be power of 2. Otherwise, we cannot perform Bitonic sequence, Bitonic sorting algorithm on those elements. So suppose there is a array given 37, the elements are 30, 70, 40, 80, 60, 20, 10 and 50. So if you want to perform Bitonic sorting algorithm, the first step is making Bitonic sequence. So first we have to perform Bitonic sequence, make Bitonic sequence. To make Bitonic sequence, we have to compare first two element and order it in increasing order, and then next two sequence, third and fourth element, and order it into decreasing sequence. Then for fifth and sixth element in increasing sequence, and the last two elements in decreasing sequence. So we will get this 30, 70, 80, 40, 20, 60, 50, 10. So next we have to do compare first element with third element and sort it into increasing sequence. Then we have to compare the third element with fourth element, second element with fourth element, and sort it in increasing sequence. And in the latter half we have to sort it in decreasing sequence. Then fifth element with seventh element and sixth element with eighth element. Then we will get this result. Then we have to again perform the increasing order sorting in between first and second element and third and fourth element, and we have to again perform the decreasing sequence in fifth and sixth element and seventh and eighth element. Then we will get this, and this is what we can say a Bitonic sequence. First four elements are increasing or in increasing order, and second four or last four element is in decreasing order. So our step 1 is completed. So let's move to the step 2. Now we have to compare the first element with the fifth, or the first element with the first element of the first half with the first element of the last half. So we'll compare first element with the fifth element, second element with the sixth element, third element with the seventh element, and the fourth element with the eighth element, and we will sort it into increasing order. Then we have to compare the first element with third element, and second element with the fourth element, fifth element with the seventh element, eighth element with the sixth element. So we have to compare them and sort it into increasing order. Then we will get this, and after this we have to compare first element with the second element, third element with the fourth element, fifth element with the sixth element, seventh element with the eighth element, and we have to sort them into increasing order. And at the end we will get our answer, and if the elements are in sorted order. So this is Bitonic sorting algorithm. There are two steps. First steps we have to make Bitonic sequence, and in the last step we have to make Bitonic sorting. We have to apply Bitonic sorting and sort our element into increasing order. So what is the complexity of Bitonic sorting algorithm? So the time complexity for Bitonic sorting algorithm is order of log n. In this case we can say for best, average and worst all the cases, the time complexity for Bitonic sorting is order of log n, and the space complexity of Bitonic sorting is order of n log n. So I think this presentation has cleared the topic of traveling salesman algorithm and Bitonic sorting algorithm. And thank you for listening to the presentation.